Good morning, everyone, and welcome to today's webinar, How to Improve Maintenance Operations with Augmented Reality. This webinar is presented by Accrete Solutions and Berger-Levrault. Before we get started, I would like to go over a couple of housekeeping items. If you have any questions during the presentation, please type them into the question box in your GoToWebinar control panel. We will bring them up during the presentation, and we will also have time for questions at the end. This webinar is being recorded and will be sent to you following the presentation for your own purpose or to share with others. In case you got disconnected during the presentation, I would request you to please click on the same webinar link that we have shared and join us back. Now, I would like to introduce today's presenters. We have Ashish Saxena. He is Vice President Global Delivery at Accrete. And we have Patrick Warren from sales from Berger-Levrault, a sales director with North America Enterprise Asset Management. Next slide. So we will start today's presentation with a brief overview about Accrete and Berger-Levrault and the work they are doing. And after that, we will present challenges that maintenance operations are facing in 2022. And then we will present the solution, augmented reality in maintenance, its cost and benefits, and how that application work in real time. That's what we will share with you. And in the end, we will share a key learning or use cases of this particular technology. In the end, as I mentioned earlier, we will have a time for question and answer. So I will appreciate if you could ask those questions. So let's start with a brief overview about Accrete. So Ashish.
Thank you, Ajay. So I am Ashish Saxena. I am the Vice President and co-founder at Accrete, and I'm responsible for global project delivery. So Accrete was formed with ex Big Five leadership team. We focus and specialize in customer service, field service, maintenance, and related business processes for logistics, warehouse management, and financials. We are a Berger-Levrault Platinum partner, as well as a SAP and Salesforce partner. We specialize in industries which are primarily, which have high value equipment. So things like industrial machinery, life sciences, manufacturing, or public sector, where it is facilities maintenance or transit maintenance, etc. And we do projects globally. As I said, we are a Berger-Levrault platinum partner, and we have brought Berger-Levrault's expertise today to talk about augmented reality and how it can help in maintenance. So we have Patrick, who's the director in Berger-Levrault, and we have the real presenter, which is Hussein, who's going to talk about the solution in detail and how it is going to work. So I'm going to hand it over to Patrick now. Patrick.
Well, good afternoon. Well, first of all, we're very excited to partner with Accrete. They have a great reputation, not only in the US, but worldwide, implemented enterprise asset software in multiple companies. So a little bit about Berger-Levrault is probably a name you never heard before. BL for short. We actually have a long history. We date back to 1463. So put that in perspective, we're older than the United States, but we were not in IT and software back then. But in 1981, we became a true IT company. That's where we do all our revenues today. We have $200 million of annual revenue. Of those revenues, we invest more than 25% in R&D in several products. We have over 200 products. The product we're going to talk about today is CMMS and EAM, which is called Call Source. It has been, it was created 35 years ago, but throughout those years, we've pushed the envelope. We were one of the first to be a pure web solution. We have a mobile app since 2012 for smartphones and tablets. So we've been innovating all the time, and we're really excited to present to you what we're working on today, which is going to solve a few problems that you guys have in doing maintenance and keeping your asset up to in good repair. So without further ado, I'm going to turn it over to Oussem, who's going to talk about augmented reality and how it can help maintenance activities. Oussem, take it over. I think we have a short poll before we turn it over to Oussem. Go ahead, yes.
Right. So thank you, Patrick and Ashish. Let we start with a short poll. It will be a quick 3 questions. So here we have a first question for you. I would request you to respond on digital transformation initiative that you guys might taking in your organization in terms of asset management. Okay, and here we have our second poll question for today. It's about the challenges you are facing. So if you could share that information. And here we are on our last poll question. The current solution in terms of asset management you are using. All right, thank you for your responses. So I would request Hussein to start the presentation. Hussein.
Hi, thank you, Ajay. So I'm Oussem Saidi. I'm a research engineer at Berger-Levrault. Today I'm going to talk about our work, research work, try to adapt or use augmented reality in maintenance work. So most of you probably are actors of the maintenance industry, and what they can see that we have a lot of today's modern equipments present in increasing complexity, both to meet the evolving customers' needs and due to the integration of embedded computing systems compared to before. So they allow for faster and more efficient production, and this is all usually at the expense of simple maintenance processes. So we end up with the maintenance industry that finds itself constantly facing new form challenges to maintain this equipment. And as an actor of the maintenance industry, we try to respond to those challenges. So we have several research projects ongoing at the moment. All of them have more or less the same final objective, which is meeting today's challenges, such as cost control, availability of equipment, user satisfaction, and will also be ready for tomorrow's challenges, such as sustainable development, flexibility, increasing technical knowledge management, and sharing that knowledge. So this covers 5 areas of innovation. We're focusing on automatic learning, so artificial intelligence, on energy management, on geographic information systems, building information models, so BIMs, IoT, predictive maintenance. So augmented reality is augmented maintenance, which is the subject of today, is one of those research projects. So we have a prototype named MixedR, which exploits the advantages of augmented reality to improve field work by assisting technicians with all the information they need at the right moment and at the right time. So what's BL MixedR? Well, before being a prototype, it was a research project at the start. We were trying to explore the use of augmented reality for maintenance activities. So this is work that's conducted in collaboration with some of our clients. So we have a close collaboration with Somfy, for example, which is one of the world leaders in automatic operation of house and building doors. And more importantly, what this collaboration allows us to do is to evaluate our work in the field, on field with the target user base, so with technicians, with maintenance managers, and in real conditions. So this is an important point because, well, evaluating the prototypes in laboratory conditions, for example, so not on the field, at the end of the day, doesn't give you the full picture regarding the performances of your maintenance solution. So, so let's delve into this subject, the technical side of it. I'm going to start by defining augmented reality. Some of you might know what it is. In simple terms, it's the superposition of virtual objects on the real world. So what we see on the screen right now is a virtual plane engine. So you can see here that there are two technicians with headsets on their head. So this is the augmented reality headset. This is called the HoloLens. And what this headset or head-mounted display allows the technician to do is to look at an equipment, which is the engine plane in here, that without having to be physically in front of that equipment. So they're going to be able to diagnostic the equipment. They're going to be able to remove parts from the equipment. They're going to be able to look at the equipment from different angles, like just getting close to it if they want more details, or maybe far from it if they want a contextual view of the equipment. And more importantly, perhaps, what we're seeing here, what you can notice, is that the technician doesn't have anything in her hands. So she can do the work, the maintenance work, without having to hold the smartphone to have all this information they have here. So this is what augmented reality allows us to do today. When we started this project, we had some interrogations, of course. Augmented maintenance is not a new concept. It has been here for a couple of decades, maybe 3 even. So we wanted to know if we were ready for it compared to 10 years ago, for example. And if we were, well, in which form? What are we going to show the technician on the headsets, for example? Which data is relevant to his work, and when are we going to show it to him? And well, finally, for which use cases? It's definitely not going to be usable to suitable for all maintenance tasks. So it's important to identify which use cases are suited to augmented reality. So what I'm going to do in the rest of this presentation is try to answer these questions, and at the same time present the prototype that we end up designing and developing at the end. So the first question was, are we ready for it? Well, if you had asked me this question 5 years ago, I'd have said, well, no, I would have even thought about it. So what changed since then? Well, since then, the HoloLens came out, which is the head-mounted display you see on the screen. It's a device from Microsoft, and if you get the chance to try it, if you ask those that tried it, they will tell you that it is stable, that it's comfortable, quite comfortable. It has good battery, but not heavy. So technology is more mature today than before, and we have development toolbox today compared to before. In terms of prices, well, while the HoloLens is not it's a bit expensive, maybe there are other head-mounted displays that are quite affordable, and we can expect the prices to drop even more in the next few years. It's similar to smartphones, really. When they were released, first in the first few years, they were quite expensive, and then today we can find $100 smartphones that are extremely performant. So another point is the content. 10 years ago, maybe even right now, we're still using paper-based instructions during intervention. Today we're slowly moving away from that, and companies are starting to digitalize their maintenance work. So this helps or removes one of the barriers to a solution like augmented maintenance using augmented reality. One last point is that today target users, so technicians, maintenance managers, are more receptive to AR, augmented reality. The big reason for that is the maturity of today's hardware, of course, but I mean, we are today more comfortable with technology than we were before. So that's what makes the target users more receptive to AR. So all these points put together, they make it so we have more potential for positive return on investment today compared to before. So from the moment we answered this question positively, we thought that it would be interesting to explore augmented reality for maintenance. So maintenance is more than the field maintenance operation. We have the workforce, we have the stock management, outsourcing, resources, security, and so on. This project focuses mainly on the field maintenance operation, but that doesn't mean that we're not going to work on one of the other aspects of maintenance work in the future. Stock management, for example, is a good candidate for augmented reality. So evaluating if the augmented maintenance prototype is interesting or worth it today comes to trying to identify where positive return on investment lies. So on one hand, we have the costs related to augmented maintenance. So the assets, technical documentation, instructions, multimedia files, so either having them or creating them. And on the other hand, we have the potential benefits, so reducing the mean time to repair, the quality of the work, knowledge we get as a consequence of producing better reports, for example, and of course, security. I'm going to delve into the technical side of the project right now. I'm going to start talking about the prototype. So first, what is augmented maintenance for us? So I have the traditional work order. Everyone knows about this one. So it's the technical requirements of the job, plus the contextual data. So contextual data is basically the multimedia support file. So any image that we might have, documentation, video that the technician can use to do the maintenance work. So we realized quickly that traditional work orders aren't suitable to augmented reality because we can do way more than just displaying the picture in front of the technician during work. So we thought about augmented work order. So this is the traditional work order, but with pre-configured behavior of the processes and multimedia files. I'm going to give an example to make clear what we mean by augmented work order. Let's suppose that technician has to look at documentation. There's procedure, a maintenance task that he has to do, and that task is described in the technical documentation of the equipment. So in a traditional work order, what the technician has to do is just take out his smartphone, look at the documentation, look at the index, try to find the procedure, and then go to the page of the procedure, and then look at that specific procedure, the specific page that describes procedure. And he's going to have to either hold the smartphone or put it near the location of the task, and then do the work. Augmented work order, the technician doesn't have to do any of this. He just has to put the head-mounted display on his head, go to the next task he has to do, and the system is going to display automatically in front of him the right procedures of the right document at the right page, and it's going to open it directly for him. So the technician doesn't have to do anything, any of that work he has to do with traditional work order. So this is what we mean by augmented work order. I gave an example for a PDF document, but we can augment pictures, we can augment videos. I'm going to talk a bit more about those later. And then we have anchored work order. So we did some experiments, and those show that positioning instructions near the location of the work where the technician has to do that task is more efficient than well displaying it elsewhere on a smartphone or tablet. So it's important to have the right information at the right place. So remember the PDF document I just talked about, the one that was opened automatically for the technician at the right page. In an anchored work order, we would also display it near the location of the task. So he just has to go and do the work, and he's going to find the right document, right page, positioned at the right location. So we use these two concepts to create our augmented maintenance prototype, which I'm going to talk about a bit more right now. So we have two phases in augmented reality. We have in maintenance in general, not just augmented reality. So we have the preparation phase where we create the work order, augment the work order, and then the execution phase. This is done by the technician as opposed to this preparation phase done usually by the maintenance manager, who can be a technician as well. So I'm going to focus on the execution part of this ecosystem, and then I'm going to come back to the preparation phase. Right. So to illustrate what a technician can do with the prototype, I'm going to put myself in the shoes of a technician, and I'm going to walk you through the whole process to do maintenance work with the augmented reality prototype. So I'm a technician. I just arrived at the location of the maintenance work. I take my smartphone out. So on the smartphone, I have a mobile CMMS, so any mobile CMMS. It's for us, it's Carl Touch, which is our mobile CMMS. And at this moment in time, I can either do the maintenance work using the smartphone only. So I just thought maybe that I don't need the augmented maintenance or the augmented reality headset at this moment. So I can do it with the smartphone only. But if it's maintenance work that I think would be better completed with the augmented reality, I can just switch in here on this intervention, say that okay, launch the augmented reality app on the headset. So at this moment in time, I'm just going to put the headset on my head, and I'm going to start the maintenance work. The first thing I'm going to see is this information panel. So on this information panel, I'm going to have the description of the work I'm going to do, the objectives, the tools I'm going to use. And as soon as I push the start button, the intervention work, the maintenance work is going to start. So I'm going to have two main windows that are going to summarize two things. So the instructions, the task I have to do, and the multimedia files, multimedia support files. So the work order window has the instructions, has the tasks I have to do. So stop the equipment, empty the equipment, and so on. And the multimedia support files window is going to show me every file I have. So whether it is an image, documentation, videos, 3D model, or so on that I have and that are linked to the maintenance work. So these two windows are the main windows, but I'm not going to use them as a technician that much. What I'm going to use, on the other hand, is what we call the dashboard. So this is the technician's dashboard. This is my dashboard. I can access it whenever I want. I just have to lift up my left hand in front of me, just like you see in here. And this dashboard is going to be displayed in front of me. So what does this dashboard have or allow me to do? I have one panel giving me all the commands I can do during the intervention. This can include taking a picture, recording a video, calling an expert if I want to be assisted remotely by someone, asking the system to guide me to the location of the next task, or just ending the maintenance work. What it allows me to do as well is access the current task. So this is task number 10. I have its description in here, and I have the steps to do this task. If I need steps, I can switch between the different steps, or I can switch between different tasks as well. I can check a task as done if I just completed it, and I can click on this icon. What this is going to do is to say to the system that, okay, I'm gonna start this task, and the system is gonna know that I'm starting this task, and it's gonna show me the relevant information to complete this task. I'm gonna show a first video showing them that illustrates the main windows and the dashboard, so how you see them in real. So as you can see here, we have two windows. They are anchored in the positioned in the environment in the work. So just open the picture in here. And I have the work order window. So it has the tasks and instructions I have to do. So these are the tasks. So these are the two main windows. As I said, I'm not gonna use them that much. What I'm gonna use, on the other hand, is the dashboard. So this one. So these are the three main windows. I'm gonna show next. So this next video is gonna show how user technicians in this now example does the maintenance work, completes maintenance tasks with the augmented reality headset. So here I'm starting task number 10. So you can see that the system automatically showed me an arrow pointing to what I need to do. The system also showed me, sorry, you can see two arrows, so I know what I have to do in here. I also have pictures, so this is the maintenance manager that prepared these pictures for me, images. So they are positioned, as you can see in here, exactly near where the maintenance work needs to be done. And as soon as I'm done with this task, I can check it, mark it as complete, and I can move on to the next task. So you can see here that we're moving to the next task. And as soon as I move to the next task, what the system does is hide the information of the previous task and show me only what I need. We don't want to see information that we don't need. So in here you can see that there is a PDF document open. You can see at the end that it's opened at page 17 because that's where the information that I need is. You can see that there are some screwdrivers in here that show that, okay, I need to unscrew this screws in here. And so I do the maintenance work, and once I'm done, I just mark the task as complete, and I move on to the next one. So as soon as I start the next one, you can see that everything is hidden, and only the information I need for the next task are displayed. So similarly here we have an arrow pointing to where the maintenance work needs to be done. The video, you can see that the video started not from the start. This is because the information that I need is not at the start of the video, but at a certain point in it, like 1 minute and 30 seconds. So we can position maintenance tasks on a video. Just imagine if a technician recorded a video of 60 minutes, for example, that show the whole maintenance work, so 10 tasks. And if another technician has to use that video, he's going to have to look in the video, in the 60 minutes video, to look for the right information, the right part of the video. Instead, in here we display it directly for him. Next part of the prototype is the what you call guiding the user. This was one of our clients when they tested the prototype. They said that okay, it's good to position relevant informations near the maintenance work, but if the technician doesn't know where he needs to go next, there is no point displaying the information near the maintenance work. So we thought about the solution to this and how to guide the technician to the location of the next task. So I have two approaches. The first one is what we call a minimap or an overview. What this does is give the technician access to a minimap showing all the location of the task. So as you can see here, you have task 10, 20, 30, 40. You can see that the weight arrow moves with the technician. So it allows him to know where he is compared to the other tasks. The second approach is the compass approach. So with this solution, the technician chooses the tasks he wants to go to, and the system shows a white arrow in front of him with the distance from the task, and the technician has just to follow that arrow to the location of next part of the work. So what we just saw was how the user realizes maintenance work, completes maintenance work using the augmented reality maintenance prototype. So now for the user to have that content displayed at the right moment and at the right location, this preparation work to be done before. And that's the preparation part in this ecosystem. So car source is our CMMS. The work order is created there, so we don't need to recreate the data, the input the information, input the pictures. As long as we have them on car source before, we will just gonna reuse them. So then we use what we call a studio to add interactivity to that work order. So adding interactivity means creating the links between the multimedia files and the tasks. So this is as easy as taking this video, for example, dragging it and dropping it on one task in here, and the link between the two is created. And then I'm just going to have to click on this pencil icon and say, okay, this is a document I needed to open at page 17. This is a video I needed to start here to end here, and I needed to play automatically. So these are just examples. I'm going to switch now to some of the feedbacks we had from our clients regarding this prototype. Well, overall, they saw that the prototype improves the maintenance work, that the mean time to repair can be reduced thanks to the availability of the necessary data to conduct the work. That allows to create complete and accurate reports by capturing better data. So duration, licensed processes, pictures, recording of the maintenance work, and so on. The prototype overall was found intuitive, efficient, and innovative. An important point was the creation of the work order. So we had one of the clients that tested the prototype saying that, well, creating an augmented maintenance work order should not take more time than traditional work order, or they just wouldn't use it. We also noticed that it's important to minimize the number of necessary actions a technician must do to configure his workspace and to access data. That's what we tried to do. If you remember in the video, technician didn't have to do anything to access data. The system displayed data for him. And of course, at the end, we need to display the right information, so relevant information at the right moment and at the right location. Now, regarding use cases, we identified multiple use cases for head-mounted augmented reality. The two main ones are complex maintenance work and training on expensive assets or infrequently available assets. So if your a company that has equipment that's constantly working, constantly producing goods, and well, you can't stop it to train a new technician and so on. You can just use the head-mounted display and simulate that work and show him how it's done in augmented reality. So instead of stopping that equipment. So for all other cases, we think it's better to use mobile augmented reality rather than head-mounted display augmented reality. Well, the reasons for that are that the cost of an augmented reality head-mounted display headset is a bit more expensive than what we would have liked to make its usage worthwhile for all use cases. Today, smartphones are more available, more affordable, and already available, and users know how to use them. So there's not enough use cases today to justify an investment in augmented reality only for use cases that aren't part of these two use cases here. We also have another use case which is interesting for augmented reality, which is remote support. So remote support would allow an expert to see what the technician is seeing without the technician having to hold a smartphone or tablet. So the expert can put custom objects in the view of the technician to show them where they need to look, what they need to do, and so on. And maybe more importantly, expert would have access to maintenance information data, so they can think with the technician. They don't have to ask them for this information or that information. They can just do the work. We also want to explore mobile augmented reality. So the reason for that are, I specified some of the reasons before, but technicians already have smartphones today, so no need to invest on new devices. So it makes sense to try to see which concepts from our work on augmented maintenance can be adapted to augmented reality. So this I'm going to conclude my talk, and I'm just going to cite the main conclusions from this work, what we try to do. So we present BL MixedR, which is an augmented maintenance prototype. We designed this prototype with experts in maintenance and evaluated it in real world conditions by maintenance technicians. So we identified multiple use cases, complex maintenance work, and training on expensive equipment. And we think that remote assist is one of the most promising use cases for augmented reality. So next steps are going to include, in addition to remote assist, enrich the reporting features of the prototype and extend the availability of the concepts introduced in BL MixedR, so head-mounted display, augmented reality, to mobile AR on smartphone and tablets. And with this, I'm going to give AJ. I'm going to give.
Thank you, Hussein. So we are now going to begin answering the questions. We have a couple of questions. So how much time required to implement AR for maintenance solutions, augmented reality for maintenance solutions?
Well, you need to prepare the work first. So preparing the work is, as I said, is going to build on information we already have on the CMMS. So from that point, it depends on of course, it's going to depend on the number of tasks we have to prepare, on the complexity of the intervention. So instead of answering this question directly, I'm going to just give an example for one task, and then we can extrapolate to a whole intervention. So the PDF I talked about before, documentation, when I said that we need to open it at page 17 and so on. So to prepare that task and that link, we just have to, as I said, drag and drop the PDF on the task we want to link it to, and just click on the on a button that's going to open a window where we're going to say, okay, page 17 for this PDF, and we'd have a couple of checkboxes to say open it automatically, or when the technician demands it. So it's doing this task, preparing this task would have taken more than 15-20 seconds. So it's quite straightforward once you know what you want and what you are doing.
Okay. We have another question. Is this solution or product available today?
Well, what we need to keep in mind is that it's prototype. We plan on making it product sometime in the next year, maybe Q1, maybe Q2. And but what's available today is the prototype. We can already deploy it for clients that want to try it in the field, that want to test it and see what it can give them in terms of benefits for their maintenance work.
Right. With this, we are close to our today's session. If any one of you want to have a live demo, so we can schedule that. You can reach out to us. Hussein, if you could go on the next slide. You can reach out to Accrete Solutions at following email address or phone number. We'll be more than happy to schedule a demo completely based on your requirement or use cases that matters to you. Thank you, Hossein, and thank you, Patrick and Ashish. And thank you everyone for attending today's webinar. You will receive a follow-up email with a link to view a recording of today's webinar. And on behalf of Accrete, Berger-Levrault, thank you for joining us today and have a nice day, everyone.
Thank you.
Bye.